Hey guys, welcome to the video walkthrough for question 5 part 2. It's asking us to color the edges of the n-dimensional hypercube such that edges that share the vertex are different colors. So no, let's say this graph, all these edges should have a different color if they meet at a same vertex. So that is a problem. Is saying it says that we need n colors, and n colors is the most that we need, so it's sufficient. N here is the dimension of the hypercube. So this is a one-dimensional hypercube, this is a two-dimensional hypercube, this is a three-dimensional hypercube, and so on. We also know that a three-dimensional hypercube is just two-dimensional like two two-dimensional hypercubes, and each edge between both of the copies. Same with the two-dimensional, it's just two one-dimensional hypercubes and then an edge between the vertices. So why is it necessary? Because every vertex is connected to n vertices. So degree of every vertex is equal to 3, sorry, n. So we need n colors, and it can be seen in this like two-dimensional example as well. Every vertex is connected with two vertices, two other vertices, so two edges. So we need two colors. Why is it sufficient? So you guys can see that I said that there are like two copies to be made. So if I say that one copy, let's say it uses like n colors, and then another copy uses n colors again. So n plus one dimension, which is basically two copies together. This is two colored, this is two colored. And then if I add an edge between both of them, it's going to be the third color, which is, and they all have to be the same because they don't share any vertex together. That is basically sort of an idea of the proof. It can be proved by induction with base case being like, so if n is equal to 1, we know that we only need one color. Inductive hypothesis says that we um, n colors are sufficient for n dimension hypercube. And an inductive step just says if I take two copies of n dimension hypercube and colorable, hypothesis, the edges that connect the two copies can be n plus 1th color, and it's the same for all the edges, all the connecting edges, as they don't share an edge. So that's just a very rough um, proof. I think it can be more concrete than that. I think it should be enough for this question. Thanks for watching.